This video demonstrates GraphWrangler, a system to query, explore, and transform relational data through the interactive creation and manipulation of graphs assisted by a predictive interaction framework. Our first demonstration shows the overall system workflow where an analyst investigates a fraud report from a customer named Alice. To investigate, the analyst connects to a database with tables for products, customers, orders, and merchants. They search for Alice in the customer table and drag the corresponding row to the graph to create a node for Alice. Next, the analyst searches for a product that Alice recently bought, a Tactics Bravo smartwatch, and creates another node. They draw an edge to explore relationships between the nodes. The system suggests possible rules connecting the two nodes. One is that Alice ordered a Tactics Bravo smartwatch. From this relationship, the analyst explores the neighborhood of first-degree nodes showing other products Alice purchased, and second-degree nodes showing other customers who bought the same products as Alice. This reveals a suspicious bipartite clique. To investigate further, the analyst notes the merchant ID in the product table and searches for that merchant in the merchant table. Then they drag the merchant to add a merchant node to the graph. Drawing an edge from the product to the merchant defines a relationship. And viewing this merchant's first-degree neighbors, they see it's likely fraudulent, since it's selling all of the products in the clique. Our second demonstration uses a national database of phone calls to show adding properties to nodes and edges to answer cuboid and crossboid queries. The user first creates province nodes by dragging one province from the caller table into the graph and setting it to show the lineage count. The system suggests inserting other province nodes too. After drawing an edge between Ontario and Quebec nodes, the system suggests possible relationships, and the user selects the one that joins the two provinces through phone calls. From that relationship, the user also adds an edge property for the total number of calls using the count of associated rows in the calls table. This property is displayed on the edges between every province. To perform a crossboid query, the user undoes the edges and adds a gender node from the caller table, and adds the lineage count. After drawing an edge between the female and Ontario nodes, the user selects the relationship suggestion for calls made between females and Ontarians. As before, the user adds edge properties for the total number of calls, then explores the total duration of calls as a weighted bipartite graph to complete the crossboid query. Our third demonstration wrangles a graph linking actors who appeared in the same movie, then shows how the full underlying graph can be imported into other software for advanced querying using our data transformation language. First, the user searches for Kevin Bacon in the actor table and creates an actor node. The user knows Pierce Brosnan and Kevin Bacon appear in multiple movies together, so they also create a Pierce Brosnan node from the actor table. They draw an edge, and the system suggests relationships where the actors co-starred in the same movie. From this relationship, they add an edge property showing the number of movies the two connected actors appeared in. To export the full graph of actors who worked on movies together, the user clicks Export. This generates a script to wrangle the underlying graph from the dataset using the created relationship and property. Running the script generates a zip file containing all node and edge CSV files. These can be imported into GraphFlow, a prototype graph database developed at the University of Waterloo. In GraphFlow, advanced queries can be run on the wrangled graph, such as the shortest paths between any two actors, such as between Kevin Bacon and Susan Sarandon. For additional details, see the accompanying paper.